Exercise 3G on page 148 is about inverses. General rule for inverses is that you take your original function, you interchange, that is swap x and y, and then you isolate y. So the equation should already be in the form y equals or f of x equals. Okay, you swap x and y over and isolate y. So let's have a look at how this works. Calculate the inverse of y equals 3e to the power of x plus 1. So the first thing I do here is interchange or swap x and y over. Oops. Let's take that. 3e to the y plus 1. So you can see there, if you compare first line to second, y has become x and x has become y. So our task after that is that we have to isolate y again. So the first thing I might do here in order to get y by itself is just target this 3 here, and so I divide the other side by 3. X over 3 equals e to the power of y plus 1. Alrighty, now it's important to remember if a y is caught up in an index like that, to liberate it we can convert the index form to log form. In the next example you'll see it's the reverse if your unknown is caught up in a log expression. But just for the moment, just remember that we can liberate that y by converting this to log form. So the way I do that is I write down log base e to the power of y plus 1 equals x over 3. And now the y is out of the index, you can see there. Alright, let's move on to the next slide. Get rid of that 3 there. Oops. Okay, now only takes one step now to get y by itself, but before I do that I might just swap sides just so the y is on the left. Nothing else really changes here. And then to get y by itself in the end, y equals log x over 3 to the base e, and we take the 1 over. There we are, there's the inverse. So there's our original, okay, and here's our inverse. We've swapped x and y over and got y by itself again. Next example, f of x equals 2 log x minus 1 to the base 10 plus 1. Now you might notice this one's in the form of f of x equals. So I'm actually going to change it to y equals. So y equals 2 log base 10 x minus 1 plus 1. Now we can use x and y throughout this problem, but there's one little thing we've got to do at the end because of it's in function form there, f of x. But I'll get to that at the end. So next thing we do is swap x and y over. So everything is identical except for x and y being interchanged, like so. And then the task is to get y by itself again. Now, you'll see y is hidden away here. Okay, it's hidden away there. So what we need to do now is liberate that. So I'm going to first of all get rid of the x plus 1 there, and by taking the plus 1 to the other side. Okay, then I can deal with this 2 here by dividing through by 2. So then I get x minus 1 over 2 equals log y minus 1 to the base 10. Alright, we'll copy that to the next slide and we'll look at what happens next. Okay, so we've got it to there. Now, in the last example, we had the y locked up in an index. Here the y is locked up in the log expression. And to liberate it, we convert it to an index form. So, 10 to the power of x minus 1 over 2 equals y minus 1. Okay, so we've converted it from log form to index form. So now, to get y by itself, what I might do first is just put the y part of the expression on the left, like so. And simply the last step is to add 1 to the right hand side. So y equals 10 to the power of x minus 1 over 2 plus 1. Now when I say last step, it's really the second last step, because you'll notice up here that the original expression is in the form of f of x. The original expression is in the form of f of x, and our answer must be in this form. The inverse is f minus 1x equals 10 over x minus 1 on 2 plus 1. Okay, so that's the form you need to put your answer in. Instead of y, f minus 1x, like that. That's the inverse, if you're using that notation there. One more example. Find the equation of the inverse f of x equals 1 minus 3 ln x plus 2. Alright, so once again I'm going to do a couple of things here. Change that to a y. And because I like dealing with log base e, the same as ln, I'm going to change it to that form. Now it's time to interchange x and y, so we get x equals 1 minus 3 log the base e, y plus 2. Okay, so now our objective is to get everything back, get y on the left hand side, so y equals. Remembering our terminology at the end, we're going to replace y with f minus 1x. Alright, I'm going to do something here. I'm going to actually make this part here, that part there, positive, and I'm going to do that by changing it to the left hand side. So it goes from being negative to positive. I'm going to leave the 1 where it is, and I'm going to take this x here, right, and move it to the other side. 1 minus x. Alright, now I'm trying to get y by itself here, so the next step I'll do is deal with the 3, and I can deal with that by dividing the right hand side by 3, like so. We'll copy that to the next slide. We can finish off the problem. Get rid of that y there. Okay, now we've got our y in a log expression. To liberate that y, we have to put it back to index form. So e to the power of 1 minus x over 3 equals y plus 2. Last step, in fact, second last step, we might put the y plus 2 on this side, like so, and then y equals, excuse me, that's just our cat meowing in the background there, so y equals e to the power of 1 minus x on 3 minus 2, and put that in index form, to put that in the correct form, it's now f minus 1x equals e to the power of 1 minus x on 3, take 2. And there we are, there's the answer. Now I'd like you please to do exercise 3G on inverses, and that is on page 149. That's all for now.